This is DEIVAMANI. Now we are going to discuss about sequence and basic examples. So we take the sequence numbers 1 comma 1 by 2 comma 1 by 3 comma 1 by 4 and so on. The first term is 1, the second term is 1 by 2, the third term is 1 by 3, the fourth one is 1 by 4 and so on. The nth term is 1 by n. This is an example of sequence of real number. Okay, sequence of real number. Okay. The basic definition: for each natural number n assigned one number, there is a real number an. We focused only on real numbers. So for example, 1 we assigned one real number a1, the 2 we assigned another real number, another real number a2, 3 a3 and so on. The n we assigned one real number an. So set of these numbers a1, a2, a3 and so on, this is the sequence. The an is nth term of the sequence. Generally they denoted by like an. This is the sequence notation. Okay. The basic examples. So generally we take natural number 1 comma 2 comma 3 and so on. So this is the sequence. The nth term is n, so denoted by n. The second example, 1 comma minus 1 comma 1 comma minus 1 comma 1 comma minus 1. In this the pattern following, the sequence nth term, the finding nth term is very important in the sequence concept. So nth term of this sequence is minus 1 power n plus 1. Let's we check. Suppose n is equal to 1. N is equal to 1. So minus 1 power 2 1. N is equal to 2 minus 1 power 3 minus 1 and so on. So this is the nth term of sequence is minus 1 power n plus 1. The another one important thing is noted. 1 minus 1 1 minus 1. So this example shows that the terms of sequence need not be distinct, right? 1 minus 1 1 minus 1. So 1 is repeated, minus 1 is repeated. So the sequence need not be distinct. So another example, 1 comma 1 comma 1 comma 1 comma etc. So this is the sequence. Each term of the sequence is 1. So such a sequence is called constant sequence. So for example 2 comma 2 comma 2 comma and so on. So all the term is same, the sequence is called a constant sequence. So the nth term is also 1. So another example, so very important example, 0 1 minus 1 2 minus 2 and so on. So this is the sequence. This sequence contains all the integers 1 2 3 4 5, the positive numbers, minus 1 minus 2 minus 3 negative number, and 0 as well as. So this is the sequence is containing positive, negative, 0. So this is the all the integers. So the nth term of the sequence is very important. So an equal to, if n is even, that is the second term, fourth term, like so when n is even, the term of sequence is denoted by n by 2 in this particular case. Suppose we put n is equal to 2, 2 by 2 1, n is equal to 4, 4 by 2 4 2, right? Suppose n is odd, 1 3 5 7, like the 1 minus n by 2. Suppose n is equal to 1, 1 minus 1 by 2 0, n is equal to 3, 1 minus 3 by 2 minus 1, then minus 2 and so on. So this is the nth term of the sequence. The another example, geometric sequence. Geometric sequence. 1 r comma r squared comma r power 3 and so on. This is the general form of geometric sequence. The common number multiplied by each term, we get another term. Okay, this is the name of the sequence is called geometric sequence. The nth term of the sequence is r power n minus 1, right? The next definition we are going to discuss bounded above. Okay, bounded above and as well as bounded below. The sequence an is said to be bounded above if there exists a real number k. There exists a real number k such that an less than or equal to k for all n. For all n. So satisfying these conditions in the particular sequence is called bounded above. So similarly, an greater than or equal to m. Okay, that means a sequence is bounded below. There exists a real number m such that an greater than or equal to m for all n is very important. That the sequence is called bounded below. A sequence satisfying both the condition in the particular sequence is called bounded sequence. So one counter example for a sequence is not bounded above and as well as bounded below. So for example 1 comma minus 1 comma 1 comma minus 1 and so on. Okay, so this is the example for oscillating sequence. The sequence is neither converges nor diverges. So this is called an oscillating sequence. For example 1 by n squared. So taking this sequence, the term of the sequence 1, 1 by 4, 1 by 9 and so on. So this sequence approaches to 0. So converges to 0. So this is the converging sequence. For example n squared, this is example for diverge sequence. So example for not bounded above or bounded below is for example 0, 1, 2 and so on, minus 1, minus 2 and so on. So there is no number satisfying the condition an less than or equal to k